Okay, open up your textbook to page 82, which is lesson 3.1 algebraic expression. So I'm going to go through and teach this lesson, and you should copy down everything that I write down, especially, and anything that I highlight or note, you should write in your notebook. Um, if you need to pause the video so that you can keep caught up on that, you should do that as we're going through this lesson. So this is lesson 3.1. And in lesson 3.1, we're going to talk about the parts of an algebraic expression. Okay? And this is nothing new. This shouldn't be new to you. The parts of an algebraic expression are called terms. Okay? Now, a like term, and we've already talked about this year, a like term is terms that have the same variable raised to the same exponent. Okay? So what that means is if you have an x and a 3 and a 2x, the x and the 2x are like terms. Okay, x, and we've talked about this before, x's go with x's and numbers go with numbers. This right here, in terms of a part of an algebraic expression, this, the 2, is called a coefficient. And it's really hard to write. The mouse. That's called a coefficient. Obviously, the x is your variable. And then the number that stands all by itself, is called a constant. Okay, so you have a variable, which is your letter, the coefficient, which is a number that is right up tight to a letter. And when you have a number right up tight to a letter, that means multiply. And then you have the constant, which is just any old number. Okay, so if I have an expression where I have like terms, when you're adding or subtracting, you can turn those like terms, combine those like terms, and add or subtract them together. So in this first example, you're going to identify the terms and the like terms in each expression. So if I have this problem right here, 9x minus 2 plus 7 minus x. Okay, I'm telling you the very first thing I would do is rewrite it as an addition problem. Okay, rewrite it as a addition problem. So to do that, you would do 9x, because that's the first number in your add-in, and then that minus becomes a plus, and that 2 becomes a negative 2. So it's the additive inverse property that you're doing. Then you add 7 to that, and then this minus becomes a plus, and then it's a negative x. Okay? So I always turn these minuses into plus the opposite. Always, 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 because then you won't make mistakes. Otherwise, later on, you could easily make mistakes. And then what you're going to do is you're going to combine the like terms. So this x can go with this x over here, and this negative 2 can be combined with that 7, because x's go with x's and numbers go with numbers. Okay, so if I combine that, I have 9x plus a negative x. When you have a negative variable like that, or a positive variable, there is an imaginary 1 in front of it. Okay, you consider having an imaginary 1 in front of it. So you have 9x plus a negative x, or plus a negative 1x. So 9 minus 1 is 8x. So that's 8x plus, and then a negative 2 plus 7 is 5. Because the signs are different, we subtract. So our answer then is 8x plus 5. Okay? That's how you would go about doing that. You would simplify your terms. Okay? The like terms are the 9x and the negative x and the negative 2 and the 7. So that is combining them. And when you combine them, the benefit of doing that is you are then able to write it in expression in simplest form. That's when it has no terms and no parentheses. Okay? That all the terms are all like terms are added together and the parentheses are gone. Okay? When you have a parenthesis, you can use the distributive property. And that's something we talked about this week before you had this lesson. The distributive property allows you to be able to get rid of those parentheses. Okay? All right. So if you look at exercise 2, now you're going to be simplifying, so you're going to be combining to get that problem. Okay? So what they did is they took 3/4 y plus 12 minus 1/2 y minus 6. So that, and they did the same thing that I would do. They turned it into 3 right here, into 3/4, and they wrote it as an addition problem. Okay? So it's 3/4 y plus 12 plus a negative 1/2 y plus a negative 6. Then you combine your like terms. Okay? So you have, when you combine those like terms, you have this y and that y. Those two can go together. And then you have this number and that number. Those two can go together. So 3/4 y plus a negative 1/2 y. Well, now you're talking about doing fractions. So negative 1/2, a negative 1/2 is equivalent to, in fourths, because we need to get that common denominator, it's equivalent to 2/4 y. So 2/4, a negative 2/4 plus a positive 3/4. So if you have 3/4 plus a negative 2/4, signs are different, so you're going to subtract, so your answer is 1/4. Okay? So when I combine my like terms, I'm going to combine that 3/4 y and that 1/2 y, which is really 2/4, because we put it in a common denominator. So 3/4 and a negative 2/4 is a positive right here, 1/4 y. Okay, now we have to combine our numbers. Okay, so we have our 12 and our negative 6. So 12 plus negative 6, the signs are different, so we subtract, so our answer is a positive 6. So it's 1/4 y plus 6, and that would be your answer. 1/4 y plus 6. You combine those like terms. Okay, so let's look at number 4. Okay, I would like you to pause your computer, and I would like you right now to do number 4. And when you're done, play your computer again, and then we'll go over it. Okay, so if I have 14, I'm going to rewrite this as 14 plus a negative 3z plus 8 plus z. Okay, so my z's go together and my numbers go together. So I have a negative 3z plus z, I moved all my z's together, plus 14 plus 8. Okay, a negative 3z plus z is a negative and a positive here. Remember, there's an imaginary 1 in front of there, okay? So a negative 3 plus a positive 1 means it's going to be a negative 2z, okay? Plus, now I'm going to put a little hash mark there so you know if that's a z. Plus, now I have 14 plus 8. So that equals 22. So that would be my simplified answer. Negative 2z plus 22. If you got that wrong, I'd like you to go back and rewatch your video. If you got it right, then you can move on. Okay? The next part of our lesson is again simplifying algebraic expressions. So, and you're doing the exact same thing as you were doing before, except that now you're going to have the distributive property, which we just got done talking about, okay? So you're going to have to add an extra step. You're going to have to distribute to get that variable alone, or to get rid of those parentheses. Then you combine the like terms, and I want to see that work. So let's do number 7 in the on your own together, and you can put that then in your notebook. So number 7 is 3 times q plus 1 minus 4. Okay, so I need to distribute this first. So 3 times q is 3q plus, and 3 times 1 is 3. And then I'm going to change that minus to a plus and make this a negative 4. Okay, now my like terms, I only have 1q, so it's 3q, and then I have positive 3 and a negative 4. So when I add those together, I'm going to get a negative 1. 3q plus negative 1. So I showed the distributive step. You have to do this. You have to show me that, and then you have to combine your like terms. And if you need to commute your order, you should do that too. Okay, so now I want you to pause your computer, and I want you to do number 8. Please pause your computer and do number 8, and then when you're done, come back. Okay, so number 8 is negative 2 times g plus 4 plus 7g. Okay, so you have to distribute this 2 to get rid of the parentheses. So it would be negative 2g, because negative 2 times g is negative 2g, because there's an invisible 1 in there, remember? Plus, and if you want to put that 1 in there, you can. It's not going to hurt anything if you do that. Negative 2g plus negative 2 times 4, because you have to do that. You can't forget to do the 2 to the 4. So that is a negative 8. And then bring down your plus 7g. Now you can combine your like terms. So you move your negative 2g, commute your order, plus 7g plus negative 8. Okay? So a negative 2 plus 7 is 5g, because the signs are different, so you subtract, plus, and then you bring down your negative 8. And that would be your answer. Okay? And that's how you would do it. If you got it right, you can move on. If not, you should go back and rewatch so you can see where you made your mistake. Okay? Okay, and then the last part of our lesson is using real life applications. Okay? So let's look at number 10. Number 10 says, what if each person buys a ticket, a large drink, and a small popcorn? How does the expression change? Okay, so it tells you that the ticket costs $7.50, the large drink costs $3.50, and the small popcorn costs $3. Okay, so you have to create an expression. So you have a group, and you don't know how many that is in that group. So it would be X times the quantity. Okay, if you're going to buy a ticket, $7.50 plus, and then X times a large soda, $3.50 plus, and then X times the cost of a small popcorn, which is $3. Okay, now you can multiply that X. I chose to put the X in front because the X is what we don't know. We don't know how many people are going to this movie. So we don't know how many people are going to be buying a ticket, how many people are going to be buying a soda, and how many people are going to be buying popcorn. So then what you do is you would not, and you could rewrite this, and I think I probably would, 7.50x plus 3.50x plus 3.00x. Now we have three like terms, so we just add those together. 750 plus 350 is 11, so that's 11x plus, and I'm going to drop that 0.00, 3x. So 11 plus 3 equals 14x. Okay, that's how you would do that problem. Okay, all right, so what I would like you to do is I would like you to tell me to do, let's see, for your, when you come to, so when you come to class, I want you to have these problems done, okay, with you showing all your work. I want you to do number 5. I want you to do number 13. And I want you to do number 19 when you come back to class tomorrow. I want you to have number 5, 13, and 19 complete when you come back to class tomorrow. Okay? Okay. Make sure you have those done.